We have each of these functions labeled, and I got you to do the synthetic division and then check, did you write the division statement for each of them? And remember, the division statement was your polynomial divisor times your quotient plus your remainder. And we get these values. Now, I'm going to also show you something in this. So for the blue one, we were dividing by x minus 1. I want you to calculate what g of 1 is equal to. For the green one, we divided by x minus 3. I want you to calculate what f of 3 is equal to. And for the black one, h of x, we divided by x plus 2. So I want you to calculate what h of negative 2 is. So that's this next part where it says here, evaluate each polynomial when x is equal to a. So it's just a matter of plugging those numbers in. All right, did you get, when you plug in 1 in for x, did you get 0? In the green one, when you plug in 3 in for x, a little bit more mental math to do, did you get 4? And in the black one, when you plugged in negative 2, lots of mental math to do on that one, did you get 0? And how are those answers related to what we found in our synthetic division?
The answer to those is the last number, the constant value.
The answer to each of those is the last number in the synthetic division, which is what in our equation?
The constant.
The remainder.
That's
Right? Because that is always the dq plus r. Which then becomes a shortcut for finding the remainder. Sometimes, but not always. I don't know, shortcut. Let's say just another way you could find the remainder. Because the synthetic division doesn't take very long. Okay? If you do the synthetic division, the last number is your remainder. That's not too hard to do. But now we have another way we could find the remainder. If I'm dividing by x minus 3, I could plug in 3, and whatever answer I get is my remainder. And if my remainder is 0, do you see that the first one is perfectly factored? The last one has started to be factored. The middle one can't be factored this way because there is a remainder. So when the remainder is 0, it tells us that we can start to factor. And in fact, this, which is called, it's on your next page here, I'll just highlight it for you. Put a big highlighter thing all the way around this. This idea is called the remainder theorem. That when you plug, if you're dividing by x minus a, when you plug in a, that becomes your remainder. And if your remainder happens to be 0, and this is on page 17, we can put a big highlight box around this as well. This is just an extension of the remainder theorem that when you plug it in, if it happens to equal 0, well then that implies not only is there no remainder, but what you were dividing by is a perfect factor. And one of the things we're going to be doing today is saying, how can we develop a strategy to factor ones like h of x? G of x, could you have factored that one directly? Absolutely. You know how to factor polynomials. You wouldn't need the synthetic division or the remainder theorem to do it. But h of x, the black one, how do I find out that x plus 2 is a possibility? Do I have to just guess and check for hours until I find one that works? No. We're going to develop that. Okay? The other thing that really, I feel that you really can see the remainder theorem and why it works And I'm going to look at the green one. Here is my division statement for the green one after synthetic division. Which is easier mental math? Plugging in the 3 into the original equation, because then you're going to have to do 3 cubed, 27 times 3, 81. You're going to have some big numbers, right? But look at when you have the division statement and you plug in 3, what happens to this?
0.
That's 0, okay? Now, I know I've talked to some of you, you've been practicing your 0 times table at night. It's really impressive, okay? If this is 0 and I times it by a bunch of things here, what's the answer going to be?
0.
0. And does it make sense that you just get the remainder? No matter which division statement you have, your division statement always has your divisor, and if you plug in what makes your divisor 0, this whole thing will be 0, giving you only the remainder left. That's why the remainder theorem works. It's based on your division statement, and it's kind of like, oh, that would be obvious. If I plug in the number that makes this whole blue circle equal to 0, what would I be left with? Just my remainder. Now these remainder and factor theorems are going to be really, really important, because by the end of the day, we're going to learn how to factor something like the black one completely. Right? Up till now, like this the blue one is probably the most complicated factoring you've done, quadratics. But now we're going to add cubes, and we're going to add powers of 4, and figure out how to factor these completely. So if we go to example 1, it says determine the remainder. And the first thing I'm going to do here is I'm going to highlight that, and I'm going to just draw an arrow, because now we have 2 methods to find your remainder. You can either use synthetic or long division. That's method 1, some sort of division. If you do the whole division, you could find the remainder. Or step 2, you can use your remainder theorem. And they're kind of both good strategies. I can find some questions where I'm like, oh, synthetic long division, that's going to be way better than using the remainder theorem. And other ones where I'm like, ooh, remainder theorem is way better than synthetic division. So they're both good strategies, but usually there's like, in certain cases, one is better than the other. And like, let's look at A, and you can decide. We'll do both methods. You can decide which one you like better. Okay? If I was using synthetic division setup, are these in the right order?
Yes.
Yes. Are any missing? Do I have to add a 0?
No.
No. So I can write, again, when you're set up for synthetic division, always doing that check first. Are things in the right order? Is anything missing that I need a 0? And if I'm doing synthetic division, what number goes on the outside?
Positive 3.
Positive 3. Bring the 2 down. 3 times 2 is 6. Add. 3 times 1 is 3. Add. 3 times negative 2 is 6. Add. 3 times negative 3. Negative 3. Add. Okay. Method number 1, using synthetic division. Or you could have just figured out, I'm going to put this in brackets here and go let p of x equal this. So now I've introduced p of x. I would need to figure out what p of 3 is. So I would plug in 3 for every x. And now I got a mental math. 3 to the 4? What's your 3 to the 4 powers? 3 times 3 times 3 times 3. 81.
Basically, in
Okay.
the long run.
Most people, when they do 3 times 3 times 3 times 3, they do 3 times 3 and get 9 times 3, they get 27. And then times 3 and they like have this pause,
60 plus 21.
and then they get 81. Because it takes longer. 27 times 3 is hardest part, right? But if you're doing 3 times 3 times 3 times 3, I would encourage you to look for other ways that are easier. Like if you do the 3 times 3 first, and that's 9, both of those blue circles are 9. What's 9 times 9? 81. Is that not a lot easier than going 3 times 3 times 3, 27, and then times 3, 81? Maybe.
I just read that.
So, a little bit of mental math tricks and strategies there. That's 81 times 2 is 162. Minus is 27 times 5. Minus 135. 3 squares 9 minus 5 minus 100 minus 45. Plus 15 plus 3.
We got it.
And you get 0. In the first example, which did you like better? The synthetic division or the remainder theorem? Most people say synthetic division. Okay.
Kinda like
Um,
the bigger one.
Like in this case, in the synthetic division, I'm thinking the hardest math you might have had to do is maybe 5 minus 6. Is that the hardest math you had to do? Or was it the 3 times the negative 2? Is that, well, that was pretty intense. The mental math was easier in the synthetic division in this one. Generally speaking, I like synthetic division except when the number's like x plus 1 or x minus 1. When it's a 1, plugging it in is really easy. 2 isn't bad. 3 was already like, ooh, 162. 3, I'm already at big numbers. Anything bigger than 3 really gets big really quick with powers. So I like the synthetic division. Generally speaking, I like it better. For 2 reasons. 1, often the mental math is not bad. And 2, besides getting the remainder, the synthetic division also gives you other information to find the division statement. But there will be some questions that synthetic division doesn't work. I'll probably, I assign it a little bit later, but oh yeah, 12B. Okay, questions? We could do the same thing for part B. It's exactly the same. So I'm not going to spend time doing it right now. But what we found out here, though, is not only was the remainder 0, we can also say that x minus 3 is a factor because our remainder was 0. So ones you can circle 4a, 6a, 7, and 8. And you can put a star beside 12b already.